In this video, we're going to review Lesson 3A.4, Interacting with Augmented Reality. We're going to learn how to identify a user tap and how it translates to real-world position. We're going to place objects in against a vertical plane, and we're going to add physics. All right, let's get started. Create a new Xcode project, Augmented Reality app template. Choose Next. We're going to call this AR Shots. Save it to our desktop. First thing we want to do is go to the view controller, and we're going to delete this reference to the scene. We'll go to the art scenes. Now you can go ahead and delete the ship scene and texture if you want, but last time I did that it crashed Xcode, so I'm just going to leave it there. We're just going to ignore it for now. Right click and choose New File, and we're going to create a new scene. We're going to call this Hoop. And in this scene we're going to remove the reference to the camera, so go ahead and select that and delete it. Next we're going to add an empty node, and we're going to call this Hoop. Then we want to add a box to make our backboard. So go ahead and select and click and add a box and make it a child of Hoop. For our box, we're going to change the size and width of the box and height. So we're going to say 1.8 and 1.1 and then 0.1. And if you take a look at that, there's our little backboard. Okay, next we want to make the hoop. So to do that, we're going to use a 3D object called a torus. And a torus is basically a circle with a tube around it. So if I click and add that, and I'm going to add it as another child of our hoop node, and we're going to change the dimensions here. We're going to say the ring radius, we're going to set it to 0.45, and the pipe radius, we're going to say 0.1. Now we want to position this so it looks like it's a hoop. So we're going to pull it forward. We still want it to touch the box. The reason for that is we're going to add physics to both of these, and we want them to not have any space. And so I'm going to go and adjust this just like so. All right, let's give these a little color so we can see them easier. I'm going to select the backboard. I want to come over here to my materials, and I'm going to say diffuse, and let's just make this snow. And then we're going to come over here to the hoop and select its color. We could make it, what, a dark, I don't know, they're usually red, aren't they? Maraschino. There we go. All right, so now we've got our objects set up. You can experiment with the scale and size of this. When I ran this example before I was preparing for this video, I discovered that depending on the size of your room and where it detects the wall, it can be really big. And if you have a lot of space, it works really well. But if you have a small space, like here I am in my office and I'm kind of not moving very far away from my desk, I'm going to shrink things down so they fit a little smaller. So with that, I want to select my hoop, the node, and I'm going to come in here and change the scale to 0.5, 0.5, and 0.5. And what that does is it makes it fit in the scene a little easier for me. Now you can experiment with that, and again, it just depends on whatever you want to do with the setup that you've got. Next, let's go back to the view controller, and as we did in the previous lesson where we did plane detection, we need to enable that in our configuration. And so in our view will appear, we set a property on our configuration to say plane detection equals, and in this case, vertical. Now, in the previous lesson, we did a bunch of delegate methods that returned and printed out a bunch of information. It helps you visualize the scene. We don't need to do that in this case because we're going to assume that it's detected properly, and then we'll add it to the scene as we go. But if you run into trouble and you're noticing that the plane detection and things aren't working, you can go back and add those delegate methods to draw on the screen in order to visualize what's going on. We need to identify when the user has touched the screen. And if we come over to our main storyboard and we look at, notice that we've got our AR scene view. Remember that we're not using any of the UI kit elements. What we want is to just identify when someone taps on the screen. We're going to use a UI tap gesture recognizer. If I go to my object library and if you don't see it, scroll way down or start typing, it's this tap gesture recognizer. I'm going to click and drag and let go, and that's going to be added to my view. And from here, I'm going to make a connection to my view controller. To see that, I'm going to go to the assistant editor, and from here I'm going to press Control, and then I'm going to click and drag. And what I want is to add a method that gets called. And this method, an action, I'm going to say screen tapped, and the type is UI tap gesture recognizer. So we want to make sure that's set. Go ahead and click Connect, and now we have our method. Let's go back to the view controller and take a look at this. In order to identify where the user has tapped and to check whether what they have tapped is a vertical plane, we need to do what is called a hit test. And a hit test is, imagine you're sending out a beam like a ray of light from the position of the screen tap at the same angle as the camera, and then if it collides with the discovered plane, then the hit test would contain the result. So to do this in our screen tapped method, we're going to implement the following. We're going to say let touch location equal sender dot location, and then we're going to say in scene view. Then we do a hit test, let hit test result equals the scene view dot hit test, and then we have a point which is the touch location, and the type is an array, and it says existing planes using extent. So that's the hit test. Now if that returns a result, then we're going to say if let result equals hit test result dot first, so it identifies the first thing that is found. Then we're going to print ray intersected a discovered plane. When this happens, we want to create and place our hoop. So let's create a function. Let me add some space around this. We're going to say function add hoop, and it's going to take a result, which is an AR hit test result. Here we're going to get a reference to the hoop scene equals scene named, and again this is based on the art dot scene assets and then hoop dot scn. From there we're going to say guard let hoop node equals hoop scene dot root node dot child node, and then this one with name, and we're going to find the hoop and set recursively to false, else it's going to return. Okay, once we found that, then we need to add this to, we're going to say scene view.scene.root node.add child node and pass in hoop node. Now, what this does is it's going to create a hoop and add it to the scene. Now the question is, where do we place it within the scene? There's value on the AR hit test result that is referred to as the world transform, which gives position and orientation of the result in the real world's X, Y, and Z space. So the values here, it's a matrix and there's a bunch of information we need to get out of it. And the following is how we will place this. If I, up here, before I've added it to the scene, I'm going to say let plane position equal result dot world transform dot columns dot 3. And from here, we're going to say hoop node dot position equals scene vector 3, and we're going to say plane position dot x, plane position dot y, and plane position dot z. Now it's going to place that according to the position of the plane that was detected. Next, make sure we update this if let result. We're going to say add hoop and then pass in the result. Okay, let's go ahead and run this and see how it looks. So now the question is, when will it detect a vertical plane? Now again, I'm in my office and I'm in a small location, and I don't want to show everything in my office because it's a huge mess. But the point is that as you experiment with this, as soon as you touch, it should add a hoop to the plane. Now if I back up a little bit, you can see that. If I can look down on my hoop, very good. If I have other planes, I can tap, hey look, there's a vertical plane there. What about over here? Anyway, you get the idea. Now, of course, now I've got multiple hoops, which is a little bit one too many. We will learn how to fix that in a minute, but first, let's go ahead and add another method that will create the basketball that we're going to shoot into our hoop. We're going to add a function called create basketball. We're going to say let ball equal, and we're going to create this as a scene node, and it's going to be a geometry of scene sphere with a radius. Now the radius depends on the scale of everything. The book references a radius of 0.25. I wanted to actually set a radius of 0.05 because I've set the scale of my hoop a little smaller. You'll have to experiment with this, but you get the idea as you start to figure out what to do based on your specific requirements. Okay, we're going to say ball.geometry.firstMaterial.diffuse, and here we're going to set a color. We're going to say contents equals UI color dot orange. Then we're going to say scene view dot scene dot root node dot add child node ball. So we're going to create a ball and add it to our scene. Now we want to place the ball directly in front of the camera. So the question is, how do we do that? Where is that position? Well, ARKit gets information from the camera and it generates a video frame, and it's stored in the session's current frame property. And the frame contains information about what the camera has captured, including the image, the timestamp, and then the position. So to position the ball at the same place as the camera, we set the transform property to that of the camera. So for our purposes, we're going to say up here at the top of our function, we're going to say guard let current frame equals scene view dot session dot current frame. Else we're going to return. Then for the ball, we're going to set the transform. We're going to say let camera transform equals scene matrix 4, and it's going to be the current frame dot camera dot transform. Then we're going to set the ball dot transform to the camera transform. We now can create a basketball. So the question is, when do we add the basketball? Well, we want to add it when the screen is tapped. Now, currently, this method will place a hoop every time the screen is tapped. So how do we fix this? Well, one way is to create a Boolean that says, is the hoop added? And you could say var hoop added and set it to false. Then you can check for that the first time the screen is tapped. And here you could say, if not hoop added, if it's false, then we can add all of this. And then one way we can fix this to get the structure, we can re-indent. And so we're saying if the hoop is added, then we're going to do this information here. And then from here, we say hoop added equals true. Once that's done, then down here, we're going to say else create basketball. So again, when we tap it, we check to see if a hoop has been added. If it isn't, then we go ahead and set it to that plane, and then we update this variable, and then we know that it's been added, and then the next time we tap, we're going to create a basketball. Let's go ahead and run our app and verify that the hoop gets added first and then the ball is added next. So we're going to identify a wall, we're going to tap, and now we have our hoop. Very good. And then from here, we're going to tap again and add our ball. Now, notice that when I add the ball, it adds it at the camera, which I had to back up a little bit to see it. But there it is. There's our ball and our hoop. The next step is to add physics, because what's the point if we add a ball and it doesn't do anything? Well, we're going to fix that. So the book talks about physics bodies, and I'll let you read that for yourself. But basically what we're doing is defining a object that can interact with the world. And so there are different properties around that. And as we do this, you'll see what I mean. But if you want more information about the different types of physics bodies, please read through that chapter. In the create basketball method, we want to add a physics body to our ball. So we're going to say let physics body equal, we're going to say scene physics body and set that of type. The type is dynamic. And then the shape is going to be a scene physics shape, which is the shape of the ball. And we don't need any of these things here at the moment. Whoops, here we go. Next, we're going to say ball.physicsBody equals physics body. Let's run this and see what happens. Okay, we're going to create our hoop, and now we're going to create our ball. And something's happening. What's happening? Well, if I look down, hey look, there goes the ball. Bye ball. Okay, so what's happening is we've created a ball and then immediately physics is acting on it and it is falling through the ground. So in order to fix this, we need to give our physics body some sort of force. Right now it's being affected by gravity and it's just falling straight down. But what we want to do is apply force to it. And we can do that by taking some properties from the camera that gives us a sense of direction. And then we can reference these values to launch the ball using force with a certain amount of power. To do this, let's go in our create basketball, and after we've added the physics body, let's create a variable for power equals float 10.0, and then let force equals, and this is a scene vector 3, and we're going to do some math that'll kind of bend your brain a little bit. Don't worry if you don't understand it, but the point is that we're taking a matrix from the camera and we're getting certain values and applying those. So for this instance, we're saying the negative of the camera transform dot M31, which is one of those columns in the matrix, times power, and this will refer to the X value. And then we say negative camera transform dot M32 times power, and then finally negative camera transform dot M33 times power. And then from here we're going to apply that to the ball. We're going to say ball dot physics body dot apply force, and then the direction is going to be force, and as impulse means true. And what that does is it's saying, does this force apply immediately? And that says true, so we want this to be applied immediately. What's going to happen, and we'll demonstrate this here in a minute, but what's going to happen is it's going to now throw the ball in the direction that the camera is facing. So the question becomes, what happens when the ball hits the hoop? Well, right now the ball has a physics body applied to it, but we haven't done anything with the hoop yet. So if I were to run this and to tap and add a ball, you would see it fly forward and it would go right through the hoop. Well, to fix that, we need to set a physics body on the hoop. So let's go up here and we're going to come down here and say hoop node dot physics body equals scene physics body, and the type will be dot static, and then the shape will be scene physics shape, and then it'll be node, which is the hoop node. Now, this is explained a little better in the book, but what we want is to set up some shape options. Because the hoop is composed of a box and a torus, which has different shapes, we're going to identify this so that it encompasses both of these and interacts properly. So we're going to add what are called options, and the options are going to be an array, and we're going to say scene physics shape dot option dot type, and that's going to be a scene physics shape dot shape type dot concave polyhedron. Say that 10 times fast. Okay, so now this adds a physics body to the hoop that accounts for both the box and the torus, the hoop part. The last thing we want to do is change what is called a collision margin. So what happens is as the two objects get closer together, we want to set kind of a buffer as to when the ball will actually react to the shape of the hoop. And to do that, we're going to set this to a very small margin. So the way we do that is back under the ball, where we have the physics body, we set the shape. We're going to add an option for this shape. We're going to say, comma, options, and it's going to be a scene physics shape dot option dot collision margin. Set that to 0.01, and that way the ball will react only when it's closer. It's about, says the book says, about within a centimeter of the hoop or rim before it bounces back. Okay, let's run this and see how it goes. Okay, let's add our hoop. And from here, we're going to throw a ball at it. Hey, wow, first time. That's really lucky. Oh, wait, here we go. Uh-oh. So obviously you can shoot at different positions. If I move the camera, notice that because the ball is coming from the center of the camera, regardless of where I tap, it's going to be showing up. Look at that. Man, I'm good. Okay. All right, you get the idea. Well, congratulations. You've now created a basketball game in AR. Pretty exciting. Thanks for watching. Hopefully that was helpful. And we'll continue with these videos, and I'll see you in the next lesson.